Okay, let's get started. So, let me just to see if like I heard there was issue with like mini quiz 6 and quiz 5. So, what about quiz 6 and mini quiz 7? Did any of you encounter issues there, or is it fine again? Okay, so maybe Canvas, like just for that week, it went like I don't know, something went wrong, but. Yeah, I mean, like the professor said, you're not gonna get. If So my guess is he's gonna drop those two for free. But yeah, okay. So today we'll go over. There's actually a lot, but I plan on moving exponential growth decay to next time, right? So, uh, yeah. So today we'll go over logarithms, right? Uh, Sort of more implicit differentiation, a version of it, and then some velocity word problems, and then we'll call it a day. So there will be a lot of word warning, I think, for homework 6. If you didn't put it, I do think there are like exponential decay and word and like other word problems there. So you're gonna see more of that. Okay. So let's go over the rule. ddx of what about like log base b, right? So what is this? Derivative of logarithms. Well, this is 1 over x ln b. So note, the easiest to remember is log e, right? Or if you like, i.e., some people write ln x. This is 1 over x ln e. And what's ln of e? Ln of e is 1, right? So it's just this. Okay, so let me just do some quick examples. Find f prime of x, when f of x is ln of x. How about that? So what should I do in this case? Yeah, chain rule, right? So my outside function is ln, and my inside function is ln. So derivative of ln is 1 over x, right? So it's 1 over the inner, which is ln x, times the derivative of inner, right? So this should be your derivative. Okay, let's do one more. What about when f of x is log 10 secant x? Yeah, chain rule again, right? My outside is log 10 of x, and my inside secant, right? So derivative of log 10, right? We follow this rule. 1 over the inner secant, right? Secant x times natural log of 10, right? Times derivative of secant is secant tangent. So this is your answer. Everyone good? So pretty simple, right? Just more rules you have to remember. Uh, Everyone follow. Okay. Oh, by the way, for those of you who, let me just go somewhere really quick. So, schedule of class. So, for those of you who are registering, for 2B, apparently, if you want, like, I don't know, if you don't like me, then avoid me. But uh, I am enrolled into, so let me do this. So I am currently for winter quarter. If you look like at 2B, uh, like right under like that sign where it says enrollment in Math 2B, Lecture B will be restricted to majors. Like, yeah, I'm TAing for this person named L. Smith. So if you wanna avoid me or take my discussion, I'm 44143 and 44144. Okay. Anyway, moving back to the stuff. So we're gonna do something harder, right? So if you recall, we have something where we had ddx of b to the x. What was this? If any of you recall. What's derivative of, say, 2 to the x? So I think this was on your homework. Someone asked this on Piazza. Like I think someone asked like something like this. But like what's derivative of this? So you're not gonna figure out how to do this homework question if you don't know this. So there's a rule, right? It's, yeah, 2 to the x ln 2, right? So this is b to the x ln b. So what you would do here, right, is chain rule, right? The outer function's 3 to the x and inner function is x squared. So this is for people who haven't done the homework yet. So that's how you do it. But let's do something harder, right? Now, what if I said, okay, that's the case where I have a variable on top, but what if we have something like x to the x? What's derivative of this? So this rule, right, only holds for, how do I say it? Numbers. Yeah, when your base is like a number. So it becomes an issue when you have a variable as your base, right? So so if I say f of x is x to the x, find f prime of x, how would you approach this? Well, there's two ways. They're equally, I'd say, equally as uh, hard, or equally as whatever, equal in difficulty. So let's do the first way. If I, I don't know how to take derivative of this, but if I let y be x to the x, what function, what special function do you know lets you bring exponents down? Like what function can I apply that lets me bring exponents, that changes exponents to like multiplication? How about that? So this is a function, yeah, log or ln, right? So I mean, for simplicity, people like ln, so let's just do ln. So ln of y is, so again, this is the same as y prime, right? Ln of y is ln of x to the x, right? Now the property of log tells me I could bring this down, right? Okay, does anyone see what the next step is? So how do I find y prime if I give you an equation like this? So this is something you know. Yeah, implicit, right? If forget this question, if the professor just gave you this and asked you to find y prime, you would implicit differentiate, right? So derivative of natural log, how would you take derivative of natural log? So from the previous slide, it's 1 over x, right? Derivative of ln x is 1 over x. So it's 1 over y prime. And then this is product rule, right? So this is 1 times ln x plus derivative of ln x is just 1 over x times x. So it's y prime over y equals ln x plus 1, right? So I'm running out of space, but y prime is y ln x plus 1. But what is y? So I'm saying I could write this as a function of x. So what is y? You just have to read back, read what I previously wrote. So right here, right? Yeah, I literally wrote it. So this is x to the x. You're done. Yeah. So one way is to use implicit differentiation. Okay. So let me show you the other way, and then you can all tell me what you prefer. So this we'll use again where this is just, let me repeat it. F of f inverse of x is x, right? So x to the x. So in other words, if you like, then f of x is e to the x. F inverse of x is ln x. So what does it mean to compose? Well, compose, what's f compose f inverse? What's e to the ln of x is x, right? That's the interpretation of this statement when f is e to the x and f inverse is ln, right? So in particular, if my function was x to the x, e to the ln of x to the x is x to the x. Yeah, I'm just, this holds for any input. So take this as my input now. Okay, from here, so basically you rewrite this function, right, as this. And so it turns out to just figuring out what derivative of this is. And what do you use to figure out derivative of this? What rule? So let me, how about this? And here, since there's a natural log, I can use, I could bring it down, right? So what rule would you use to find derivative of this? No. Exponential rule, the exponential rule is just this, right? But a priori, but we don't have e to the x right now. We have e to the x ln x. So what rule should I use? You only know so many rules, right? There's power rule, exponential rule, quotient rule, product rule, chain rule. Pick one. So, I mean, it can't be quotient. You're not dividing by anything. Uh, inside you're doing product, but what's the main thing? It's gonna be chain, right? Let me just say, chain rule, right? My outer is e to the x. My inner is x ln x, right? So derivative of e to the x is e to the x, so it's just this, right? And then derivative of x ln x is, we did this before, times derivative inner, it's, what was it? Ln x plus x times 1 over x, right? Ln of x plus 1. Now, from here, e to the ln x ln x is x to the x. Why did I write this in red? So this is equal to x to the x ln x plus 1. Yeah, that was the answer, right? If you go back right here. Yeah, so there's two ways, right? You could use chain rule by like using the inverse property, or you use implicit differentiation. Whichever one works for you, right? But for me, I'll do the implicit differentiation way, because I think that's what most students like. But okay, everyone clear on this? So you don't have to do it my way. You could do it the other way. Everyone clear? So let's do two more for practice, yeah. So, and once you, so yeah, so on the midterm, I guess, do you have a second midterm? I don't know if you do, but on the final, right? If you see variable on the exponent, that's a hint to natural log and then implicit differentiate. So f of x is x to the sine x, right? So I'm gonna do it the implicit differentiation way. So y equals x to the sine x. I see a variable on top, right? It's a function of x on top. Maybe not variable, but like function of x on top. So I natural log, right? So now I could bring the sine x to the bottom. And then this is just implicit differentiation, right? Derivative of the left-hand side. So if I take derivative of both sides, I get that 1 over y prime is, and then this is product rule, right? Derivative sine is cosine times natural log plus derivative natural log, I went over, is 1 over x times sine. So if you like, y prime is y times cosine of x times ln x plus sine x over x. But what is y? Well, y is x to the sine x, right? Everyone good? So I did one where the function on the exponent was not just x. I mean, the process is pretty much the same. Yeah, so this should become, okay, let's do one more. So let's do one where the bottom is not x. So you see, like, it doesn't really matter, right? Like, even if both is not, if it's cosine to the sine, it's the same exact process. Like, but I'm just doing x because derivative of it is nice. No, it doesn't have to be just x on the bottom or top. So natural log again, right? Same exact process. Ln of y is x ln of cosine of x, right? So here, right, implicit differentiate. So 1 over y prime is derivative of x is 1 plus, okay, derivative of, how do I take derivative of ln of cosine? So that is chain rule, right? My outer function's ln x, and my inner function is cosine of x, right? So derivative ln x is 1 over x, so it's 1 over cosine, times derivative of cosine is negative sine, right? And then I keep the x, right? So this is just product rule. And then y prime is y ln cosine of x minus x sine x over. And again, what is y? Y is this. Oh, sorry. But by the way, this might look confusing, but I mean this, right? Not so. Yeah. Make sure you know to not. I don't mean this. Yeah. I meant cosine of x to the x. Just so we are all clear. Okay. That might confuse people. So y is cosine of x to the x, and then ln of cosine minus x sine over cosine. Okay, everyone clear on this? Yes. So key point, variable on top, natural log. If you're gonna take away something from this. Okay, so let me just say this holds even if you have a number on bottom, right? So if you recall, we said d dx of b to the x is b to the x ln b, right? So an example would be what we did before. 2 to the x is 2 to the x ln 2, right? So if you forgot this rule, you don't need to remember this rule because you basically do the same thing, right? Y is 2 to the x. How do I take derivative of 2 to the x? Well, let's natural log both sides. Then this becomes x ln 2, right? And let's implicit differentiate. 1 over y prime. Okay, what's derivative of x ln 2? I'm testing you all. Yeah, what is derivative of x ln 2? No. What is derivative of 5x? What is that? No, not a trick question. Okay, I mean, what's derivative of 3x? Yeah, it's just ln 2, right? ln 2 is a number. So derivative of ln 2x is ln 2. Yeah. So it's sort of like that quiz question. I'm not sure if it's the one that glitched, but I asked what was derivative of this, right? this and this are two different things. Yeah. Like derivative e to the x is e to the x, but derivative e is not e. Yeah. Because e is a number. So derivative pi is 0, derivative e is 0, and then derivative e to the x is e to x. Right? So like ln x and ln2, these are two different things. This is not a constant function. This thing is a constant. Yeah. So I hope you all got this correct. By the way, I didn't check. I don't really check the scores, but I'm guessing some people might have made this mistake, right? Some people might think it's this. So I'm pretty sure they would have gotten through. They know pi is a number, so it's 0. But some people might put this instead, which is not true. Yeah. So this is just ln2, right? So this is y prime equals ln2y, and y is 2 to the x. And you see it, yeah, so you don't really need to memorize this rule, right? Just if you don't want to, just know that to solve it, it's natural log, implicit differentiation, or the other way I showed you. Well, which I don't like, but yeah. Okay. Everyone clear? So let me just say, yeah, okay, let's move on. So I'm just gonna finish with word problems, yeah? So I'm just gonna remind you all how to do like these. I think they come up pretty common on like midterms and like finals. So yeah, okay. So these are, I'll say, velocity word problems. Yep, they're back. So let's do, some questions. The height in meters of a projectile shot vertically upward from a point 2 meter above ground. Hopefully you can all read this. I'm taking this from the book. So with initial velocity. And I don't know if you noticed, but WebAssign just takes problems from the book and then they change the numbers. But yeah, of 24.5 meters per second. So there's a high chance I'm doing your homework, but I mean, I figured like the book problems, are better than the ones I think of. So is h equals 2 plus 24.5 t minus 4.9 t squared. So this is like your distance, right? Height, distance, whatever you want to call it. So A, let's do this. Let's do A. Find the velocity after 2 seconds and 4 seconds. So how would you do this? You just read this problem. So think of height as like distance, right? Height, whatever, position is all distance. So what's velocity? Yeah, right. If you think of velocity is just, it's if you think of velocity as rate, right? That like distance equals rate times time. Divide by time, rate equals distance over time. But distance over time is sort of like, rise over run, if you like, the change in y over change in x. So it's the derivative, right? It's slope. So, but in this case, we know how to take derivatives now. So we know how to find the slope of this at 2 and the slope of this at 4, right? In the beginning, you didn't know. If you didn't know about derivatives, you only knew about slopes of lines, right? But now we know more than that. So what's the derivative of this? So this is 24.5 plus or minus. What's 4.9 times 2? 9.8 t. So, oh, sorry, no, it's just this, right? So here, right, what's the velocity after 2 seconds? Well, you plug in 2, right? So after 2 seconds. Yeah, I'm sorry, I don't know if we need a calculator for this. I didn't really check. But it's going to be this, right? Let me put this so it doesn't look like a minus sign. So 24.5 minus, what is that, 19.6, I think? Is it 19.6? Yeah. So this is 4.9, I think. And then after 4 seconds, I'll let you do this one, but 24.5 minus 9.8 times 4, whatever this is. Yeah. Okay, part B. Ren does projectile reach maximum height? So this is very common. It'll ask for like maximum height, minimum height on like, this is a very common question I see on like finals. So how would you do this? Okay, let me rephrase the question. How would you graph this? What does the graph of this look like if you are to sketch? Good. It's when the derivative is 0, but why? That's the correct answer. It's when the velocity when the derivative is 0, but why? So how would you graph this function? Okay, parabola, upward or downward? Yeah, it's because the negative sign, right? The negative makes it downward. So what's the maximum height of the parabola? It's at this point, right? And this point is pretty much when your derivative is 0, right? When your tangent line is flat. So in this case, it is the actual max, right? But later on, I'll give you a hint, right? Later on in 2a, like if you have a function, right, wherever derivative is 0, right? Locally, I mean, if you look like locally compared to like points here, it's the max, right? Compared to points here, it's like this point's like the minimum, right? So you see, like later on, you'll learn that derivative being 0 sort of means like you have like a local min and or local max, right? Because if you view like a hill, right, derivative is 0 when you're at like the bottom of the hill or top of the hill. Yeah. Or I guess this is a hill, this is like a trench, but like you get what I mean. So here in this case, this is a parabola, right? The height is when derivative 0. Well, our derivative is 24.5 minus 9.8 t, right? So if we set it equal to 0, you get negative 9.8 t equals negative 24.5. Whatever this is, yeah. um, 9.8. Everyone clear on this? So shouldn't be too bad. Okay, so there's also a word I want you to learn. So they ask this a lot too. So a particle moves with position. Function. Yeah, so when you see position, it's like distance, right? Distance, height, position is pretty much like the same in Math 2A. Yeah. I mean it's not the same in like physics and stuff, but for our purposes, what we're testing you on, it's pretty much, you know, position, distance, height is like the original is like F, velocity is F prime, right? Just think of it that way. So minus 2t squared plus 20t when t is bigger than or equal to 0. So there's two questions. A, at what time does particle have velocity 20 meter per second? And what I want to tell you is the second part. At what time is acceleration 0? So I'll tell you what to do when you see the word acceleration. It's always the same in Math 2A. I mean, I don't know what it is in physics, but I know what it is in math. So, but before that, let's do part A. How would you do part A? So it's asking at what time is velocity 20? So what should I do? What's velocity again? Right, so velocity is the derivative. So it's asking ren is the derivative 20, right? Just think of it that way. So you take derivative, so 4t cubed, I'm taking derivative of this, 4t cubed minus 12t squared minus 40t plus 20 equals 20. So what is this? Equals 0. Factor out the t. Did I do this correctly? Let me see. Yeah, okay. 4t squared minus 12t. So the reason I'm being skeptical is because I didn't check whether the numbers are nice, so I don't really want to. Okay, so when this is 0, so it's when this is 0 and when this is 0, right? T squared minus 12t minus 40 equals 0. Please do not make me use quadratic formula. 3t minus 10. Okay, this is not bad. 2t minus 5, t plus 2. Okay, so it's when t equals 0, right? T equals 5 and t equals negative 2. I'm saying one of them cannot happen. Which one is it? Yeah. So why? If you just think logically, time. I wrote t bigger than or equal to 0 here, but even if I didn't write this, you can't be negative 2 seconds, right? It doesn't really make sense to have negative time, right? Uh, I mean, or else there's like time travel. But yeah, so yeah, so time is like positive always, right? So it's t equals 0 and t equals 5. Now, I want to go to the second part. Acceleration, you should always think of is double the second derivative, right? It's derivative, or if you like, acceleration is, you can think of it two ways, right? One, derivative of velocity. Two, second derivative of, distance. I mean, in this case, position. What was the last problem? Height? Yeah, height function. Yeah. So it's like the F double prime. Yeah, that's acceleration. So it's like the slope of the velocity. How is your velocity changing? So again, to figure what this is, you take derivative, right? So derivative of my this is my velocity equation, right? So derivative of this would be 12t squared. What is this? 12t squared minus 24t minus 40 is 0. Okay, so we could divide everything by 4. 3t squared minus 8t minus 10 is 0. Does this factor nicely? I hope so. If not, then it's Pythagorean theorem. Not Pythagorean theorem, it's quadratic formula. No, the right before is 6. Oh, this is 6. Does that make it easier? Yeah, I think you might need to use quadratic formula, sadly. I'm just going to use it. Equals negative b plus minus square root 36 minus 4 times negative 10 times 3 over 2 times 3. So t is whatever this is, yeah? 36 minus, so plus 120. What is this? Whatever this is. Yeah, let me just say 36 plus 120 over 6. Yeah? I see it. Is everyone clear? Yes? No? Yeah, so when you see acceleration, just think of it as like second derivative. So I guess that will conclude today. So let me just say next time I'll go over exponential decay, right? And I'll also go, yeah, that'll be the main, this will be like word problems. And then whatever comes after that. Yeah. Everyone good? Clear? Okay, cool. I'll see you all Thursday.